Today we discuss t-test for two population mean test. To apply t-test for two population mean test, we have to know the condition for using t-test. These are the two conditions for using t-test for two population mean test. The first condition says that when both sample sizes n1 and n2 are less than 30, population variances are unknown and equal, and population is normally distributed, we can use t-test in that case. So we repeat once again. When both sample sizes n1 and n2 are less than 30, population variances are unknown and equal, and population is normally distributed, we can use t-test. In the second condition, we see when both sample sizes n1 and n2 are less than 30, or one sample size is less than 30, other is greater than 30, and population variances are unknown and unequal, population is normally distributed, we can use t-test. We repeat once again. When both sample sizes n1 and n2 are less than 30, or one sample size is less than 30, or other is greater than 30, population variances are unknown and unequal, and population is normally distributed, we can use t-test. Now if we summarize these two conditions, we can present it as follows. So in a summary we say, this is a summary statement. In a summary we say, when both values of n, that means both sample sizes are less than 30, or one is less than 30 and other is greater than 30, and population variances are not known, that means are unknown, and population is normally distributed, we use t-test. We repeat once again. When both values are less than 30, both values of n are less than 30, that means both sample sizes, or one sample size is less than 30 and other is greater than 30, and population variances are not known, or that means unknown, and population is normally distributed, we can use t-test. So these are the conditions for using the t-test. If these conditions are satisfied, then we can easily use t-test for two population mean test. Otherwise we cannot use t-test in that case. So these are the conditions for using t-test. Now we discuss the testing method available for t-test. So there are two different testing methods that we are going to discuss. One is called test statistic method, another is called confidence interval method. But there is another different method that is called p-value method. But we are not going to discuss p-value method in this case, because to find p-value from t distribution table, it is quite difficult finding p-value from t distribution table. In most of the cases we need software, and for this reason we are going to omit p-value method over here, and we discuss these two methods only. So first to discuss the test statistic method. To apply this method, first we need to know the formula for t-test. So this is the formula for conducting two population mean test for t-test. So this is the calculated t, or in other sense this is the calculated value of test statistics, and as you see over here, this is the first sample mean, second sample mean, first population mean, second population mean. This is a combined variance as a sigma square, the first sample size, second sample size. To calculate combined variance, we use the following formula. The formula says that sigma s square equal, we multiply first sample variance with n1 minus 1, then we add this term with the second component, that is equal to second sample variance multiplied by n2 minus 1 and divided by n1 plus n2 minus 2. So once we get this value, we put it over here, then we calculate the value of t. So after calculating the value of t, we can compare this value with the critical value of t to decide whether we should reject null hypothesis or fail to reject null hypothesis. Now we discuss the rejection rules for test statistic method. The rule says that if the absolute value of calculated t is more than, as we see over here, it says if the absolute value of calculated t is more than the one tail and two tail critical value of t, in both cases we reject null hypothesis. We repeat, if the absolute value of calculated t is more than the one tail and two tail critical value of t, in both cases we reject null hypothesis. We reject when calculated value is greater than the critical value. In the second case, we say that if the absolute value of the calculated value of t is less than the two tail and one tail critical value of t, we fail to reject null hypothesis. We say that we fail to reject because calculated value is less than the critical value. If we summarize, we can summarize as follows. In a sense, if the absolute value of the calculated value of t is more than the one tail and two tail critical value of t, we reject null hypothesis. On the other hand, if the absolute value of the calculated value of t is less than the one tail and two tail critical value of t, in both cases we fail to reject null hypothesis. So these are the rejection rules for using test statistic method. Now we discuss the confidence interval method. So confidence interval, to apply the confidence interval method, we need to know the formula, confidence interval formula for t-test for two population mean test. The formula, this is the difference between the two population mean, as we see here, mu1 minus mu2, difference between the two sample means. This is the combined standard deviation. Now we need to pay attention over here. This is the t alpha by 2, and this t alpha by 2 says that we use total critical value of t. In constructing confidence interval, we have to use total critical value of t, otherwise our confidence interval calculation will be wrong. So we all time use total critical value of t. Whether hypothesis is one tail or two tail, it doesn't matter. We all time use total critical value of t. Now if we add this component with the difference between the two sample mean, we find one interval value, and that interval value is equal to this. As we see, we refer this first interval value as mu1 minus mu2 single prime. Now if we minus this term from the sample, the difference between the two sample mean, we get another interval value that is referred as mu1 minus mu2 double prime. Now these are the two interval values that we can easily calculate from this fundamental confidence interval formula for t-test for two population mean test. Now once we get the confidence interval values from this using this formula, now we can apply confidence interval testing rules to decide whether we should reject null hypothesis or fail to reject null hypothesis. If one interval value is less than and other interval is greater than 0, we fail to reject null hypothesis according to this method. So as we see, this is the difference between the two population mean, and this is all time 0, and we see that this is positive, one value is positive and another value is negative. If one value, according to the formula, according to the rule, we said if one value is negative, another value is positive, and in between we have 0, in that case we fail to reject null hypothesis. We can show this as follows. This is the difference between the two population mean. This is one interval value that is equal to that is negative, and this is another interval value that is also positive, and then this is our constructed confidence interval, and in this interval we find our population mean that is equal to 0, and since we find our population mean in this interval, we fail to reject null hypothesis. So in the second case, if two interval values are positive, in that case we must reject null hypothesis. This says that if two interval values, if both values are greater than 0, in that case we reject null hypothesis, because we see these are the two interval values that are more than these are the two interval values that are more than 0, because this is positive and this is also positive, and our interval, and this is our difference between the two population mean, and this is 0, and since these two interval values are positive, we reject null hypothesis. As we see in the graph, this is the difference between the two population mean, and this is our interval values, two interval values, and this is our positive interval because our two interval values are positive, and in this interval we do not find the difference between the two population mean that is equal to 0, because it is located over here. Since we do not find the difference between the two population mean that is equal to 0 in this interval, we reject null hypothesis. In the third case, when the two interval values are negative, we reject null hypothesis. So if both values are less than 0, as we see, if both values are less than 0, in that case we also reject null hypothesis. So we see that in this case the two interval values are less than 0, and this is the difference between the two population mean that is equal to 0, and this is 0, and these two interval values are less than 0, and so we reject null hypothesis. If we show graphically, we see the following picture. From the graph we see that this is the difference between the two population mean that is also equal to 0, and this is the two interval values that are less than 0, that means negative. So this is the negative interval, and in this negative interval we do not find our hypothesis population mean difference that is equal to 0. So since we do not find 0 in this interval, we simply reject null hypothesis. So we sum up as follows. If both interval values are negative, we reject null hypothesis. If both interval values are positive, we reject null hypothesis. If one value is positive and another value is negative, we fail to reject null hypothesis according to the confidence interval testing rules. And we have also discussed the rejection rules for test statistics method, and the different testing method that we do for two population mean test for t-test, and that we do for t-test for two population mean test. Now we have also discussed the condition for using t-test. So to sum up, we use t-test when the two sample sizes are less than 30 and or one sample size is less than 30 and other is greater than 30, and population variances are not known, and population is normally distributed. If these conditions are satisfied, then we can easily use t-test to conduct two population mean test. Otherwise, we cannot use t-test to conduct two population mean test. And that's all from this video.